Good morning, everyone. This is just a quick lecture on pests and some pest management options that we have, including the use specifically of DDT and the understanding of biomagnification and bioaccumulation. So grab your pencils, grab your whiteout. I'm just going to label this pests for now. We'll cover some DDT and bioaccumulation and magnification. All right, today's date is the 29th. So let's get started. So first of all, when we talk about what a pest is, right, a pest has obviously a ton of definitions, but we're just going to label it any organism that is a nuisance. So any organism that is a nuisance, especially to us as human beings, right? And so when we're talking about soil, and specifically pests when it comes to agriculture, let's talk about agricultural pests. So let me go in here. So when we're talking about agricultural pests, we have a whole bunch. We have insects. These guys, as we know from hearing from part of our problems yesterday, they extract liquids from plants and can do some major damage, even killing them. We have weeds that are issues. We have arthropods, right, which are insects. Specifically what we talked about yesterday, some arthropods were aphids, beetles, right, worms, mites. These are a specific category, right? So insects, I should say, are arthropods. But some big arthropods that we'll talk about or have discussed are aphids, beetles, worms, mites. And then microbes or pathogens that come in and kill. And when we think about these, we want to think about fungus and viruses. And so we see all of these things in our agricultural realm. So how do we control them, right? How do we control these guys? So let's look at some control. And I'm going to first start off with all kind of like toxic chemical solutions. And just so we get an understanding of what these are. So number one, let's go with pesticide. This is just a general term for anything that kills pests, right? So that's a general term for anything that will kill a pest. And then we get into more specific. So we actually have herbicides. An herbicide will kill weeds. Specifically, typically, a lot of times herbicides are used on plants like corn and soybeans, because we've got herbicide problems, weed problems in these types of fields. Number three, we've got insecticides. Right, insecticides are going to kill just our insects, our pests, as far as insects, some of our arthropods. And insecticides, we see a lot of time, an example would be spraying cotton. A lot of pests come on cotton. Another group is our fungicides. And our fungicides obviously kill fungus. We have, like I said yesterday, a huge problem when it comes to fungus and potatoes. So typically we see fungicides being sprayed on potatoes. And then, I don't know if we hit this in yesterday's, but we have also rodenticides. And these will kill rodents. Let me erase that here. Rodents. Now, all of these means, right, all of these guys, if I could encompass all of this, these all kill with chemicals. Right, these all kill with chemicals that are toxic in some form or another to the pests that we're trying to kill. So these are all chemical based. All right, and so we have then different philosophies of control, right? So different thoughts. Different thoughts on how we control. So philosophies of control. And the first one, oops, which we just saw from above, is chemical, right? And so I'm just going to put C above. All right. The next we have is ecological control. And so when we talk about ecological control, typically we want to protect our plants from damage. Right? We want to protect our plants from damage, but we're not eliminating the pest completely. Not totally eliminating pest. Right? We don't have total elimination, in other words. And when we talk about ecological control, we can really then also talk about biological control. And if we're talking about biological, we're talking about the use of living organisms, right, to control other pests. The use of other organisms, we can use things like parasites that would eat our pests. We can use other pathogens that maybe will kill them, or even predators to these guys. And so an example, right, an example here would be the ladybug, right? Ladybugs will eat some of the pests that we want to get rid of. So that's just an example there of a biological control. We can also do things, we'll see here on Friday, we can do things genetically. I'm just going to put genetics. And we'll talk about this later, but our GMOs, which we'll see. And then a really good way or philosophy that I think is this IPM that you research, which is the Integrated Pest Management. With integrated pest management, what happens is we use a combination of methods, so a combo of methods. And typically this is something that's sustainable. We're using things like oils, soaps, minerals, other ecological things, so we're maybe some chemicals, we're combining everything. This is more of a long-term solution. And the great thing about this is it has minimal environmental, ENV is environmental impact, right? Minimal environmental impact. Now, with our integrated pest management, if you listen to anyone talk about this, we'll look at like the life cycles of pests, you know, when they're in their larval stage versus when they're actually in their adult phase, and at different times, different solutions, right, to these problems would be better. Maybe it's a chemical spray at some point. Maybe it's just the physical pulling of the crops, right? Maybe it's a crop rotation. maybe it is bringing in a predator to eat the larva, which they'll eat, but not the actual adult phase. So we look at the life cycles of the pests. And when we think about integrated pest management, we don't think zero tolerance, right? We're always going to have pests. What we want to do is decrease the pest enough so that we actually see yields in the agriculture, whatever we're trying to grow, okay? Because we're never going to have zero pests. That's just not going to happen. But we want to set a threshold that allows us to yield something. Okay, so let's talk about these chemicals for a moment. So here are like chemicals, and what happens, right? We're going to talk a little bit about promises of these chemicals and then problems with them, inherent problems. So when we talk about chemicals, first of all, we've got chemicals from like a long time ago, like our first gen chemicals from like, I don't know, anywhere from about the 1400s to the 1800s. And these chemicals, these first generation chemicals, were things, especially early on in the 1400s, we were using things like mercury, lead, what else is in that group? Maybe some silver, but mercury and lead, we'll just leave it at that. We were using other plants, right? Botanicals, some type of natural plant extract like nicotine, for instance, to kill off other pests. But once again, even though we're using these, we still have pest resistance. So eventually this leads to pest resistance, right? No matter what we're using here. Resistance. I'm going to run out of room. And then, you know, time goes by. We learn more about science and technology. And then we get like a second generation going on where we get many chemical pesticides, like there's, you know, thousands, or I don't know, let's just say close to 1,000 different types of chemicals that we can use. So we'll just say many, right? A lot, so many that I'm not going to list them. But what I want to do in particular is talk about the DDT. DDT is the chemical formula. You don't have to write this down if you don't want to, but it's C6, what do I have? H9Cl6. This is dichloryl diphenyl trichloroethane. DDT for short, which you probably all have heard of. It was actually found, this chemical was found in about 1837 and then like rediscovered in, I don't know, 1938 by a guy named Mueller, Paul Mueller. Now, the reason that this was so significant is because at the time, if you look at the timeline, this was World War II. Okay, and during World War II, we had people in Japan, in various areas of the world that had a lot of swamp, mosquito. We had a lot of problems with typhus. Okay, so typhus is from some lice. So lice carry typhus, so there were typhus issues due to being in these wet areas, these very humid areas. We had a lot of problems with mosquitoes and malaria. And so during World War II, right, DDT is made by Mueller, and it's like this saving grace. It supposedly saved millions, like 25 million lives. And DDT is still used around the world in areas, right, where we have a lot of humidity to decrease, once again, malaria. And so at this time, right, at the start of understanding of DDT, we thought it was a great pesticide to use. Like I said, the WHO said, you know, during this time, probably 25 million people were saved. It's a really cheap chemical to make, and they thought it had really low toxicity. But by the late 1940s, what they start to see is like once again, an increased resistance, right? To some insects are increasing their resistance to DDT. We're seeing toxic things occurring when it comes to fish because it's getting into our water supply. It's highly toxic to fish. We note that it's a lipophilic, so it's fat-loving. It's stored in fatty tissues. It builds up over time, they're noticing, and the half-life